This problem is about the distribution of IQ scores. We're given the mean, the standard deviation. And we want to find the sample size necessary to estimate the mean, the average IQ score, if we want to be 95% confident that the sample mean is within 4 IQ points of the true population mean. So we're going to want to use the week 5 spreadsheet, and there's a tab at the bottom. Let me just pull that up, make sure we're clear. It's the minimum sample size tab, and that lets us know what size sample we need to get the result that we want. And so we're working with means here, finding the minimum sample size needed to estimate a population mean. And so in the green boxes here, we want to enter the confidence level we want, the standard deviation that we're going to have, and the error, how close we want the population mean to be to our sample mean. And it gives us back the minimum sample size needed to reach those results. In this question here, it's about conducting a research poll, a survey. A large number of people are asked a question, and in this problem, it's whether global warming is a problem that requires immediate government action. And out of that sample, this many people said that yes, they think it's a problem that requires immediate action. And so we want to know if this survey result reflects that over 50% of the entire population feels that same way, that action is required. So for part A, what's the best estimate of the proportion of adults who believe that action is required? And the only data we have to go off of is this survey. So the results from that survey give us the best estimate. So let's open up the week 5 spreadsheet here, and we're doing proportions, trying to find the proportion of people who agree with this statement. And so we have the total number of people that were asked, and we have the number of people that said yes, action is required. And so that sample proportion, which is 995 out of 783, so if you just did this on a calculator, 995 divided by the total that were in the survey, you get this result here. That's what the sample proportion is. And so that's our best estimate for what the population is, because that's the only data we have to go off of in this particular situation. So that's our estimate. And now we want a 95% confidence interval. So we would type in 95% for our confidence level. And down here, it gives us the lower and the upper limit that, our sample came back with this proportion, but we're 95% confident that out of everybody, the entire population, the proportion's somewhere in between those values. And so how do we kind of interpret that? That's what part C is about. Is there strong enough evidence to claim that the majority is in favor of immediate government action? Well, since we're 95% confident that the proportion is in between these values, that means we're confident that the proportion is definitely above 50%, because this entire range of values is above 50%. And so we're confident that the majority, more than 50%, do agree with this statement that immediate action is required. For this problem, it deals with hypothesis tests. And overall, it's saying that illegal drug use has dropped from this percentage down to 9.9%. So the problem is phrased here that in a large high school, they do a survey of that school. They get a random sample of this many students, and 92 report using illegal drugs. So the principal is claiming that illegal drug use in that school is below the national average, the current average, which is 9.9%. And so this setup here would reflect that principal's claim. Here's what the population proportion is, 9.9%. That's a decimal, 0.099. And the alternative hypothesis is the principal's claim that the proportion in that high school is actually less than what the overall average is for the population. So you would want to come into the week 6 spreadsheet. You have a level of significance, or alpha, of 0.05. That was stated in the problem as the significance level. Our null hypothesis is given as 9.9%. This is the total number of people in the survey, and this is the number of successes they had, which in this case was reporting illegal drug use. So This is what the sample proportion is. You get the z-value for that. And this is definitely a one-sided p-value. The chances of being at this sample proportion are even further less than, because if you remember, our null hypothesis was only one-sided, that we were less than, our alternative was one-sided, that we're less than the null. And so those values are what you plug in here for your z-test statistic and your p-value. And then we're going to make a conclusion. And since this p-value is larger than alpha, it's not enough evidence to reject the null hypothesis. And so that's what we conclude here. Yes, it's true that the proportion of our sample was below 9.9%, but it's not far enough below to really reach any conclusive claim that we can reject the null and assume that the alternative is true. And this problem here is similar to the last one, where we're challenging a previously assumed proportion, so we're going to be using a hypothesis test here. So in a previous year, it was found out that 61% of households nationwide use natural gas heating. A survey is now collected, and we get back that now it's 62% from that survey. Well, is that a large enough change for us to conclude that this 61% is now no longer accurate, that it has changed? So since we're just trying to test whether it has changed, where it's going to be a two-tailed test, that the current proportion is now not equal to what it used to be at 61%. And so we'll come in and use the hypothesis test week 6 spreadsheet, type in our level of significance. The null hypothesis is that the proportion is still what it used to be at 61%. This is how large our sample was, and this was what the sample proportion came back as, 62%. And so we get the information we need down here in the yellow. This is a two-sided test, since we're just testing for not equal to, for a change either greater than or less than. And so we enter those values in here for the problem. And now I guess the most important part, in my opinion, of the question is interpreting those results. And in this case, our p-value is much larger than our significance level. And when any time that happens, anytime the p-value is larger than alpha, our significance level, you do not reject the null hypothesis, because there's not sufficient evidence to reject it. So in this case, it would be there's insufficient evidence to support the claim that the percentage of households using natural gas has changed. So in other words, the alternative hypothesis, there's insufficient evidence to support it.